Nanomaterials are catalyzing the technological revolution. They are incredible and have potential to revolutionize the world we live in. Let us see how. Nanomaterials are extremely small in size. They are thousands times smaller than the width of the human hair, and this tiny size makes them very useful for all kinds of practical uses. The substances containing particles of diameter or an object with any of its dimensions in the range of 1 to 100 nanometers is considered as a nanomaterial, and this is the size range of molecules, atoms, and subatomic particles. The properties of nanomaterials are different compared to the same substance in the bulk form. This means the material could change when it goes from bulk to nano form. For instance, the gold at the nanoscale can have different colors like blue, pink, or purple. As you can see here, the window glass is stained with nanoparticles, and the red, blue, green colors are gold and silver nanoparticles of different sizes and shapes. So the object behave differently at nano regime. Their physical and chemical properties change with the size and shape of the material particle. Hence, the properties of nanomaterials can be tuned by manipulating the size and shape of its constituting particles. This feature allows to produce nanomaterials with unique electrical, optical, and magnetic properties. These materials are creating great impact on the technological world. The sources of nanomaterials can be natural, incidental, or engineered. Nanomaterials are found all around us and form a complete cycle of environment. They can occur naturally. They can be created incidentally as the byproduct of activities like combustion reactions. They can also be produced purposefully through engineering to perform a specialized function. Natural nanomaterials are bounded in the living system, exhibiting remarkable properties due to their inherent nanostructures. Some of the examples are like spider web silk, which is a nanofiber lighter than cotton and stronger than steel. About lotus flower, we know lotus bloom in the mud, but have you ever seen any dirt on the lotus leaf? No, because it is covered with the self-cleaning coating of nanomaterial. The geckos are known for their incredible sticking ability. It is because of the strong adhesion due to the nanostructured furs on their toe pads. The beautiful colors of butterfly are the result of their nanostructured wings. And moth eye is covered with the nanostructured mesh, which doesn't reflect light, which is incident on it, absorbs almost all the light incident, and that is why it allows it to view in the dark and dim light conditions. The story of nanomaterials is very interesting, which can be viewed in my another video, which is titled here, available on YouTube. There are many sources of incidental and engineered nanomaterials as well. The engineered nanomaterials, popularly known as ENMS, are most prodigious class out of all kinds of materials, and their properties are tunable due to the size effect, and this makes this material to be manufactured artificially. and they are creating huge impact on the technology, leading to numerous novel industrial applications. They are composed of metal oxides, polymers, or carbon-based materials. They exhibit unique physical, chemical, and biological properties as compared to their bulk counterparts. Carbon nanomaterials like graphene, fullerene, carbon quantum dots, or carbon nanotubes are also very special kinds of materials. And they are very useful and revolutionizing the technology due to their incredible properties. So we can summarize that the nanomaterials are lighter, stronger, corrosion resistive, that makes them very durable. And due to the size effect, they are more reactive, functional, and have exceptional conductor properties that can also be tuned. So the durability along with the tunability makes nanomaterial capable of revolutionizing the industry and technologies. Let's now discuss the numerous industrial applications of nanomaterials. Mixing nanomaterials, fibers, and polymers in the building materials like cement improves the performance of concrete in construction industry. The nano-enhanced concrete will make products like building or roads much stronger and durable. Nanomaterials can also make fibers soft, durable, breathable, water repellent, fire retarding, or even antimicrobial. Here is a product shown in the picture which is available for the online purchase, and they claim that is nano enhanced to keep it cool, to make it water repellent, and due to this nanoparticle enhancement, it reduces odors as well. Nanomaterials are more reactive, so they are very effective in removing unwanted substances in water treatment processes. And also the filters made by nanomembranes can have very fine openings to block impurities. So they are very efficiently used as filters for water purification and desalination. Nanoencapsulation is very powerful and important process in nanotechnology. In this, substances are encapsulated as an inner core within nano-dimensional shells made up of non-toxic polymeric material. Encapsulation protects the substances from adverse environments and provides advantages of stability and control over accurate delivery of materials. The applications of nanomaterials in agriculture industry include nanopesticides, nanofertilizers, bioremediation, nanosensors, and nanocapsules for effective delivery of systems. Nanoencapsulation of filters and pesticides slows down their release and improves utilization, thus reducing the environmental problems associated with this. The effect of fertilizers and pesticides can also be prolonged with nano effects. Nanomaterials help fertilizers and pesticides to be fixed in the soil for plant root absorption and reduce their loss. It also controls unwanted movement of materials to minimize the soil and groundwater pollution. Nanoemulsion is also very important in this field. They are mixture of liquids that do not dissolve in each other and have droplets of one liquid scattered in the other, such as emulsion of oil and water as shown here. The nanoemulsions are manufactured for improving the delivery of the active ingredients. Nanomaterials can improve the quality, safety, and nutritional value of food. The take-up of nutrients and supplements can be enhanced by encapsulation. Also, they have antibacterial properties that is used for improving food safety. And interestingly, nanomaterials can create low-fat mayonnaise, spreads, and ice creams. Nanomaterials are used in wide variety of product, processes, and devices in aeronautics. They are used in electronics and display with low power consumption, sensors, structures, and paints, and whatnot. In aeronautic industry, nanomaterials are used to produce lighter structures without compromising their strength and other mechanical properties. The intervention of nanomaterials in medicine industry have improved the drug design, delivery, and medication system enormously. It has also reduced the size of tools, which allows to image, diagnose, and fight the diseases more accurately and efficiently. Nanomaterials are exceptionally powerful in treating diabetes, cancer, and many other genetic diseases. Nanomaterials can deliver drug to specific parts of the body, such as cancer cell, and can be controlled to release them exactly at accurate position in the right time. And moreover, nanocarriers can be removed off the body very quickly after delivering the drug. Altogether, the side effects of chemotherapy are reduced, which makes treatment more effective. Nanomaterials have great impact on renewable energy technologies by contributing to increase efficiency, cost effectiveness, and sustainability. They find widespread of adoption in the renewable energy solutions. Nanomaterials play central role in the present semiconductor electronics due to their unique electrical properties. And nanoelectronics is emerging as a game changer. Nanomaterials are used in electronics to make devices faster, smaller, and more powerful. They can also improve the density of memory chips, reduce power consumption, and help to reduce the size of transistors used in the integrated circuit. Or overall, we can say that they are leading toward miniaturization and better performance of electronic systems. They operate at lower voltages and currents, making them energy efficient. They offer great versatility in the design and fabrication of electronic systems. Such electronics can be integrated into flexible substrates for developing bendable, stretchable, and wearable devices. Currently, we are living in the era of silicon-dominated semiconductor electronics since the last few decades. Nanomaterials hold immense potential for efficiently replacing silicon in various applications, and worldwide efforts are going on to overcome the challenges like their scalability, reproduction, and their integration with existing technologies. Nanomaterials exhibit novel functionalities as compared to the traditional semiconductors, and one of its examples can be quoted in form of quantum dots that can emit light of a specific wavelength depending on their size, making them useful for display and lights like LED applications. This phenomena occurs due to the quantum confinement effect in the nanoregime. In the picture, you can see a colorful world can be created with quantum dots. The schematic of quantum dot display system shows here how quantum dots enhance the colors of the electronic display. This phenomena is so important that the Nobel Prize in the year 2023 in chemistry was awarded to the scientists Bawendi, Bruce and Ekimov for conducting their research on quantum effect and quantum dots. Nanomaterials are so powerful that the science fiction that is shown in the movies can be reality in nanotechnology. Nanomaterials can achieve unimaginable possibilities and capabilities in various systems. Nanotechnology was referred in the Marvel movie Avengers Endgame, and this example is always given when the nanotechnological developments is discussed. The superhero Iron Man's suit to attain impossible goals appeared exaggeration for now, but the scientists and engineers can in future develop smart materials, self-powering, biological power, and smart clothing comparable with such sci-fi capabilities. It is portrayed that the suits of Iron Man and Ant-Man are extremely strong in these movies, which seems fantasy at this time. But this may be possible with nanotechnology in future. Nanotech can be used to create materials with higher mechanical strength and can in principle create super strong suits. The research has been shown that the carbon quantum dot fibers can be used to create strong fabric to make safe suits for soldiers. The Spider-Man web is also very interestingly presented as the combination of strong strength and elasticity in these movies. Nowadays, manufacturing very strong and elastic fiber like the Spider-Man's web is no longer a fantasy. These materials are biomimic of the spider's silk, which is made up of 1 nanometer thick protein molecule. It is lighter than cotton and stronger than steel. It can bear the bigger load than its size. Spider silk can be turned into a super material. It is claimed that a thumb-thick spider silk can hold a jumbo jet in air without breaking. It can withhold hundreds of tons of load in full speed without tearing off. Isn't it all amazing? And don't you agree that the nanomaterials are catalyzing the revolution? If you are interested in knowing more about this field, please catch me up on my YouTube channel Purnima Speaks, where technical facts for Generation Z are presented. You can also reach out through scanning the QR code given here. And keep on learning and enjoy the power of knowledge. And thank you for watching.